videos for you. All right. Now, when do you use combinations and permutations? When we do what? Lottery. Now, of course, if you've had me for 120 and you wasn't texting while I was talking about the lottery, why, in South Carolina, why did we, in my opinion, this is my opinion, why did South Carolina have such a fit when the lottery came? Because South Carolina and Mississippi, we're always last in what? Education. So we're all a bunch of what? DAs. Exactly. We're all a bunch of dumb Southerners. Alright? So we ain't got sense enough to know when to stop buying lottery tickets. And babies outside in the parking lot running around with diapers on, starving to death, right? While we're inside buying lottery tickets. Have a good doctor's appointment. Bubba goes out and buys one lottery ticket. And if he gets the first 5 numbers right, that's a 1 out of 5 million chance around you. That's the first 5 numbers. If he gets the 5 numbers right in the Powerball, that's a 1 in 75 million chance. 1 over 175 million. So, to make things short, you don't have to write it down, just listen. And those are corresponding with the back of the lottery card. I rounded, I think it's 175, 600,000, something like that. And this is 5,600,000, but I just rounded. Bubba decides he's smart. And instead of buying 1 lottery ticket, he buys 10. And he figures the probability there, so he buys 100. And he buys 1,000, 10,000, 100,000. He buys $1 million for $1 million lottery. Buys 1 million tickets. What's wrong with that reasoning? Still what? Still a 0% chance, because we round in real life, in the real world, we round everything to the hundredth place. Money, gallons of gas, whatever we round to, we usually round to the second place. So, 0% chance. So that's why Bubba's kids are running around. He's in there trying to play lottery or trying to pick out numbers for $1 million.
It's smarter about
tickets. Huh?
It's smarter about strategy.
Yeah. I guess. But let me ask you this.
Well, I won $500 with my first
I have won $1,000.
I'm saying it's smarter.
I don't want to win $1,000. You know why? Because then you have to put it on taxes.
I didn't know. I didn't know how to do that.
Really good.
But I didn't have like the receiver.
Oh, listen to that. I didn't win it. No, $1,000 or more you have to.
That's
why
what
I
I'm
want to
saying.
win.
She just gave it to me.
I just want to win 500. That's all. Then you don't have. You
don't
can't
go to
get it. You have to go
Columbia.
to Columbia to get 1,000 more. That's why I don't want to win 1,000. I want to win 2,500.
No, but I think you have to go if it's more than 500.
No, because you can get it at 2 different stores. So anyway, who's smarter? Bubba buying 1 million tickets or Bubba buying 1 ticket? Buying 1 ticket because he has the same percentage. And people say, no, that ain't right. Okay, 1%. If you want to go that far, 1%. You buy 1 million tickets, you up your chances 1%. Even if you got 100,000, you don't get a 1%. That jump, and plus, not many of us walk around with $100,000 million in our pocket. All right, 1% just jumping up.
Vegans have small things.
Oh, okay, well, it must be awful.
We usually leave the rest on our private jet.
Oh, okay. Well, what happens if you put it in order? See, this is no order. This is the way that the game is played. This is order. This is, I'm sorry, no order. This is order. So what happens if you play in order? Does the probability go up or down? It goes down. He has to buy 10 million tickets to get close to the 1%. If the lottery numbers are in order. If you have to have them in order in which you don't. Now, why did South Carolina have a fit? Because all of South Carolina, since we're done, we're going to run out and do this. Because we ain't got sense enough to know what moderation is. Now, how do you get these numbers? Well, there's two formulas that you need to know. Well, actually 3 or 4, but I'm going to go ahead and show you which ones you need to know. Somebody tell me what time it is. Huh?
20 after 10.
Okay. Dana, is he telling me the truth? Okay.
I wouldn't mind.
Yeah, you would.
I would not.
Yeah, you would. Here we go. There's 2 formulas, but I'm going to go back and show you all 4. There it is. All right. Here, blow them up a little bit, man. Please. All right, I want you to write the examples down for these because the examples are going to help you out on the test. The fundamental counting rule, when you just multiply the numbers together, is when you have a 2 or 3 sequence, like a key code, and you got to type in 2 or 3 numbers, and they consist of a letter and a digit. And then you would just multiply 26 times 10. Because how many letters do we have in the alphabet? 26. How many digits are between 0 and 9? 10. So 26 times 10 is 260. So there's 260 different combinations of a letter and a number. That is fundamental counting rule. So for your, like if you was to do a 4 digit key pad or key, whatever, what is it called on the ATM card? PIN number, thank you. Personal identification number. If you was to do 4 digits, and you would have to know if they repeat or not. If you can repeat them or not. I think you can repeat them. Alright? If you can repeat them, then it would be 10 digits per each. So that would be 10 to the 4th power. Which would be what, 10,000? So there's 10,000 different key codes for your personal identification number. Now, you've also got to put that with your checking account number too. And how many digits there? Because you got to get the checking account number right to get the, if you were going to be the person, now if you had the card, then all you got to do is run 10,000 numbers through. Yeah. They'd cut off and keep the card by then. The factorial rule. This is used when you have a example. The number of ways that 5 letters can be arranged. The word smile. How many different words can you get out of the word smile? Well, you can get a lot, but some of them don't mean anything. Different arrangements of the letters would be a better word used than word. Different arrangement of the word smile would be 5 factorial. How many different ways can A, B, C, D, and E be arranged? 5 factorial. Now those are, if I give you 10 questions on the test, 1 and 2. In other words, I'm going to give you 1 of these. I'm not going to spend a lot of time. These are the 2 I'm going to spend a lot of time on. 3 and 5. Well, you're going to have to just read 3 first. 3. Permutation has to do with what? Order. CEOs. When you hear of officers, CEOs, COO, president. When you hear about that, that's order. First, second, third, and fourth place is order. Now, the permutation is NPR, National Public Radio. N is always your biggest number. N right now is 15. 13. Alright? N in here is 13 right now. How many people are brown-eyed? 5. That would be your R. Because R is always smaller than N. N is the biggest number. On your calculator, math, probability, somebody tell me, number 2 or 3? I think it's number 2. Somebody look on your, huh? Yeah, number 2. So on your TI-83 or 83 app on your phone, it's going to be math, probability, and number 2. Combination is math, probability, number 3. And I think factorial is number 4. Now, if you have factorial on your calculator, then you can still do this in a timely manner. If you have a Sally Homemaker calculator or a Sally Homemaker calculator app, which just has 5 times 3, and that's it, and adding and subtracting, then you're not going to be able to do this. You're going to have to use the Excel spreadsheet, or you're going to have to get an app, or you're going to have to get a scientific calculator that at least has factorial. And still, if you do it that way, it still takes a few minutes to do it by hand if you use the factorial. So I would highly suggest that you get a TI-83 app. You either get a TI-83, borrow one for the test, or you use the spreadsheet, and I'll show you how to do that. Not today, but I'll show you how to do it. It's real easy. Combin, C-O-M-B-I-N, and permute. P-E-R-M-U-T, and we'll do that probably Wednesday because we don't have time to do it. Number 5, the combination rule. And I'll shut up after this. The combination rule. This is what you use with a lottery. And that's the questions I will give you on the test if I can find them in this book. It probably doesn't even have. Lottery. And there's only one difference. And that is in the denominator, you multiply by what? R factorial, which is your small number. So how do you do the lottery problem? I'm going to show you that right now. And then I'll shut up. The lottery problem, if I can find, I have the eraser and I can't even use it. The lottery problem, you set it up like this. And you have to look at the numbers, but the numbers are, you buy one lottery ticket, and the 1 has to go up top. Because you can't win the lottery if you don't what? Play the lottery. And with each question, and this is any question that has to do with the lottery, is assuming that you buy one ticket and it's not said how many you're buying. Just assume you're buying 1, so the 1 goes on top. If you don't put the 1 on top, you get it wrong. No matter if you cry, beg, whatever, you still get it wrong. Over 2 sets of parentheses because you got 5 balls and you got Powerball. We're talking about the Powerball lottery right now in South Carolina. So we did it this morning in 120. And that would be, I think it's 59 combination 5 or something like that. 1 through 59, you pick 1 through 59 numbers, or 0 through 59, I can't remember which one it is. 59 numbers, it'll tell you. And how many digits are there in the Powerball? I meant the first 5. There's first 5 numbers. And then the second one, you pick like 35, and there's only one Powerball. And that's how you would set it up. And that comes out to be 175 million. Okay? And that's where we got Bubba's numbers while ago. In Unit 2, what do we cover? 7 and what? Is it just 7, Chapter 7? Okay, because we're about to end up Chapter 7. Wednesday, we will go over some more of the lottery and some more combination and permutation problems. Okay? Let me call the roll. And somebody hit my button, please. Vanna, would you hit it for me, please, so it won't